Hello wonderful person, this is Anton, and in today's video I wanted to answer a relatively simple question. What would happen if our beautiful planet Earth was actually tidally locked to our sun? I'm going to explain the concept of tidal locks, and we're going to demonstrate what's actually going to happen to our planet as well. Welcome to What the Math. And let's actually start by defining what tidal locks are. I think the most famous example is our own moon. Our moon is tidally locked to our beautiful planet Earth, which is right there in the back. It's kind of dark, hard to see. What tidal locks mean is that the moon always faces the same way to the Earth. That's why you always see the same face if you look up into the sky and try to look at the moon, because the rotation of the moon equals to the orbit of the moon. In other words, one rotation around Earth is exactly the same as one orbital period of the moon. So here we never really see the so-called dark side of the moon, but we always see the so-called bright side of the moon. There are some other examples in our solar system. Pretty much all of the major moons of Saturn and Jupiter also are tidally locked to them. So like for example, if I were to go to Saturn here and look at Titan, the rotation of Titan, which is right here, is 15.9 days. In other words, one rotation takes about 16 days. At the same time, a single orbit around Saturn is also 15.9 days. So all of these satellites are also tidally locked. Another really cool example is actually Pluto and Charon. These are the so-called dual planets, or dual dwarf planets, or basically dual system. They don't really have a name yet, not the official name at least, but they were kind of unofficially, or kind of still are unofficially known as the double planets. That's because they're relatively similar in size, and because they orbit around one another in a relatively interesting way. But we'll talk about these two objects in one of the future videos. For now, all you have to know is that they're actually also tidally locked to each other. So Charon is always facing the same side of Pluto, and vice versa. Pluto is always facing the same side of Charon. Even though here it's kind of hard to tell because I think their rotation have been slightly changed in the game. So what would happen to Earth if it was actually tidally locked to our sun? And this question is actually very important because a vast majority of exoplanets we found, in other words, planets outside of our solar system, somewhere out there orbiting stars like, for example, red dwarfs, are predicted to be tidally locked. Now, this question needs to be answered. So what would actually happen to a planet, specifically a habitable planet like Earth, if it was actually tidally locked to its star? What would it look like? What would be on its surface, and would it be possible to survive there? So today we're going to do just that. We're going to tidally lock our planet, either by using the button right here called Tidal Lock, or by basically starting a simulation where you can actually observe this in real time. Here we go, climate simulation with tidally locked Earth. But let's just press the button first, and we're also going to enable climate, which is already actually enabled, and observe this for a few years. We're going to see what happens to our beautiful planet if it's basically tidally locked right in this region. So Africa and Europe are now always facing the sun, and North America, South America, and Australia are always in the dark. Now let's run the simulation and find out what's going to happen. So we're going to accelerate time just so that things start happening a little bit faster. When the game starts processing climate information, the planet kind of starts blinking a little bit, and you can actually see that happening right now. It's kind of a glitch, I guess, but that's because we're suddenly getting all these ice caps here. All right, and here we go. So this is 2 months per second. The blinking has stopped, and you can kind of see right on the dark side right there. Look at that. A huge ice cap is forming. On the bright side, everything is pretty much brown. Everything is scorched. And you can kind of see it here if I move really fast with the planet's rotation. So basically Africa is completely brown with an exception of some forests right here in the middle. And on the dark side, even though you don't really see it, it's essentially all ice. It's completely covered in ice. And interestingly, there's only one place on Earth that has climates now. Every year, right here in the so-called Twilight area or Twilight Zone, which is not just a TV show but also a location on a tidally locked planet where basically you have the day meeting the night, so right around here, so right here, this line, which I can't seem to stop at. But anyway, let's actually maybe slow down the simulation so I can show it to you. So this right here, this is Twilight area. So right there, it's basically going to be where we're going to have climates, but unfortunately, as soon as I slow down the simulation, the ice caps disappear, so I have to restart it again. I have to make sure that it's running really fast. So here we go. So we have the ice caps, we have the climate area, which is probably the only place where the humans can now survive. And then we have the very, very large ice-covered area. Basically, this is all ice, frozen water all over the place. All of the continents are covered in it. Possibly some of the biggest ice caps we've ever had in our life. And the African and European continents are essentially scorched and devoid of life. And just for fun, let's actually start this simulation as well, which is specifically meant for this sort of experience. And here, it's really the Australian and the Pacific region, including the western part of the US and Mexico, and Canada, of course, are basically exposed to the sun. And also there's a huge chunk of Siberia here, whereas Africa, Europe, and so on, and the Middle East, of course, and India, are essentially covered in darkness. So in this situation, it's going to be the opposite. We're going to have all of these ice caps form right here all over the place. You can see them forming really fast. And the rest of the region, including Australia, and surprisingly not Russia though, are basically covered in super dry deserts. Essentially, all of the areas here are too hot to survive, and there's no way any kind of a life would actually flourish there, except for some extremophiles that can survive in such conditions. And once again, only the Twilight area right here in between the ice caps and between the hot region are the regions where we can have sort of seasons, and we can have, like right there in Antarctica, you can actually see that there's actually seasons happening. Because ice is retreating and coming back again. So maybe this is actually the only area where we can kind of survive. But everywhere else, we would pretty much be dead. And so what this suggests is that all of those exoplanets we've discovered might actually have these types of conditions on them. They might actually have these extreme conditions, with huge areas being completely covered by ice and darkness and are being essentially very, very cold, unless there is some sort of a really good atmospheric exchange where warm air can be carried around the planet. But chances are it might be actually like this. This might be the face of many of the exoplanets we've discovered, with one large ice side and one large scorched side, with the Twilight area being the only region where we can actually kind of colonize and settle on. And well, that's essentially it. That's all I wanted to talk about in this video. I wanted to present this really interesting phenomenon, especially since a lot of the exoplanets we've discovered seem to have this arrangement. Now, maybe we'll find a planet that doesn't actually have a tidal lock to its star, but since the majority of exoplanets that we think might be habitable often resemble this one right here, which is Proxima Centauri, the closest exoplanet to us and the closest star to us. We think that, also especially since like 90% of stars are essentially red dwarfs, or smaller in size and smaller in mass. So we think that many of these planets might actually be tidally locked and might have this type of an arrangement. So here, if I were to once again place a tidally locked Earth around Proxima Centauri, you would actually see that it would very likely start doing exactly the same thing. So here, assuming Proxima b looks anything like this, it's very likely it's also tidally locked. So assuming that it is tidally locked like we actually think it is, it's going to have this really beautiful but very scorched surface facing Proxima Centauri and very cold area on the other side that is going to be pretty much too cold to live on. Which of course also means that maybe, just maybe, there aren't that many planets out there, just like our planet Earth, that we can actually settle on and live on comfortably. Even though we might be able to find planets that are kind of similar to Earth, their orbit and their rotation might actually make them uninhabitable. And anyway, So that's all I wanted to talk about in this video. And hopefully now you know what would happen to our planet Earth if it was tidally locked to our sun, and also you know and understand a little bit more about tidal locks in general, and especially when it applies to things like exoplanets and finding an Earth-like planet on the outside of our solar system. If you've enjoyed this video, don't forget to subscribe, and don't forget to share this video with someone who enjoys watching and learning through video games. I'll see you guys tomorrow. Come back tomorrow to learn something completely different, related to science, space, or maybe math. Or maybe just watch me play a video game. And anyway, space out guys, I'll see you later, and as always, bye-bye. And before we finish this video, let's maybe collide something with our planet Earth and see how it affects all of these unusual formations of ice on the surface. Let's select our friend Pluto and launch it right there into that ice cap and see what actually happens to our beautiful tidally locked Earth if it basically receives a collision of really large proportions. And check out this ice disappearing instantly. Beautiful. Anyway, I'll see you guys later. Bye bye.